Please turn on your cameras, everybody. Ronak, Spreha, Advik, Iha, Tarun. Asti. So in your batch, what is the last thing? Class monitor किधर है? हाँ जी, क्या था last discussion? हाँ? अरे ये तो जनरल स्टेटमेंट होगी. एग्जैक्ट बताओ क्या चल रहा था. लिखा भी था आपने. Yes, anyone else? नहीं, कौन सी रिएक्शन कहाँ पे पहुंचे थे? एपॉक्सीडेशन कर रहे थे. ओके. स्ट्रॉन्ग. विद शुगर दे दो इस बार. एनर्जी चाहिए थोड़ी. हाँ जी. चलिए एक बार फटाफट हम लोग एल्कीन की रिएक्शन में क्या क्या कर लिया एक बार बताइए. एल्कीन में क्या क्या कर चुके हो? चेक योर नोट्स क्विकली. स्प्रेया, आस्था. हाँ. नो नो, आपका अब कराया जाएगा, टेंशन मत लो. बस जस्ट हियर मी आउट. सब कुछ होगा. हाँ, डोंट वरी. Whatever I'll be doing today will be completely independent of earlier classes. Don't worry. Okay? I'll make sure that you understand everything. बताओ. मोल कॉन्सेप्ट सैटरडे रख लें? फ्राइडे रख लें? कल रख लें? आप लोग डिसाइड करके बता दो एक बार. रूपेश जी विल कोऑर्डिनेट विद ऑल ऑफ यू. ठीक है. 15 से सारा रिवीजन होगा. टेंशन ही मत लो, है ना? ओके. ये चेक करिए, आपके नोट्स हैं ये वाले. एपॉक्सीडेशन आपके नोट्स हैं आई थिंक. ठीक है. चलो आगे शुरू करते हैं आज का डिस्कशन हम लोग, है ना? किधर पेन किधर गया भाई? रुपेश जी पेन किधर है? सर लेगा अपने साथ ही. चलिए भाई शुरू करते हैं. सो विल स्टार्ट विथ certain things and then we see how we take it forward from there, right? Write down the heading. Hydroboration, oxidation. आई होप किसी ने भी नहीं किया आपके बैच में, राइट? कंफर्म ही? कोई बात नहीं. Hydroboration oxidation. Write the heading Hydroboration oxidation. I think we have not done this, right, in your batch. Everybody, take it. Very important reaction for all the exams. Tarun, please turn on the camera. I'll make sure that everybody will understand everything, okay? But आपको बस attention अपना यहाँ पे रखना है, ठीक है रौनक? चलिए पहले तो reaction समझते हैं कि इसमें होता क्या है. So let's say I give you a question, CH3, CH double bond CH2. In this reaction HBO, इसको short में बोलते हैं HBO, Hydroboration Oxidation. HBO channel में है, channel था या है भी? है, ठीक है. So this is HBO. If you do HBO on this, product is CH3, CHH, CH2OH. पहले note कर. First you write down the product. Voice is low. Voice is low. एक second. कितने लोगों को voice low लग रही है? एक बार hand raise करो. तो आपको अपनी voice बढ़ानी है. बाकी सभी को आ रही है. Spriya, can you hear me? Okay. Astha, Raunak. Okay. ठीक है. We have completed epoxidation, no? Last class. Epoxy formation. अच्छा ठीक है चलो वो भी करा दो पहले इसको कंटिन्यू करो ठीक है CH3CH H CH2H. Now let's say you have this question. You are doing HBO. So the product is CHH CH2OH. First you observe the product. Okay, all of you please observe the product. And please tell me what is the observation. Yeah, so this is pi bond and OH is coming where? Outer side, right? So it is Markovnikov or Anti-Markovnikov as per your understanding? Anti-Markovnikov. All of you understand Markovni and Anti-Markovnikov? Normally, the rule is negative part should join where H is minimum. That is Markovnikov. You are getting on other way, right? So these are the example of Anti-Markovnikov addition. Note down this word. Asa, is it clear?
Sir, can you please repeat what is Markovnikov?
Okay, so write down Markovnikov rule is Markovnikov. Okay, rule is negative part join on minimum hydrogen. So anti-Markovnikov is negative part join on more hydrogen of a double bond. Is that okay?
Yeah, okay.
Minimum hydrogen, जहाँ पे H कम होगी सबसे, वो Markovnikov, right? Fine. So the question is how this is happening and what is this HBO and what are the reagents for it. So write down reactants. Yes, this kind of reaction will happen. So what are the reactants for HBO? So write down B2H6 with THF as solvent. Step 1. H2O2 OH minus. So this is how the reaction will progress. B2H6 THF, H2O2 OH minus. So when I say 1 and 2, first you react with this, second you react with this. This whole thing is known as hydroboration oxidation. This complete reaction is named as hydroboration oxidation. Very important reaction for any exam you are preparing for. सारे exams में पूछ लिया जाता है. We'll talk about it one by one. Any difficulty in this part? Any issues in this? लिख लिया? So अगर मैं आपको क्वेश्चन पूछूं, let's say अभी हम मैकेनिज्म पे जाएंगे, but let's say I ask a basic question. ऐसा कोई क्वेश्चन आपको एग्जाम में आ गया and you are doing this reaction. So what is the product? What is the product? Can you draw the product first of all? इधर पे OH लगाऊं या इधर पे लगाऊं? इधर? इधर. Correct? इतना समझ में आ रहा है सब? Can you mark the answers of this type question? Is it clear, everybody? Iha, Astha, Spriha, Advik, Tarun, Dhriti, everybody. Spriha. Yeah, this is anti-Markovnikov addition, right? This is example of anti-Markovnikov. Yeah, Tarun, please tell me once again. We'll talk about this whole mechanism, don't worry. We'll show you why it is happening anti-Markovnikov, okay? So first you write down this part. Is it done? No, it's not correct. So let's see why this reaction is becoming anti-Markovnikov. So we'll take a reactant. So let's take this reactant, CH3, CH double bond, CH2 and try to do this mechanism. I hope all of you have copied this whole thing. Yeah, take your time. Yeah, they're all anti-Markovnikov. All are HB. HB. Yeah. Markovnikov is, you will join the negative part to a position where H is minimum. जैसे आप ये क्वेश्चन सॉल्व करते थे पहले, CH3 CH डबल बॉन्ड CH2. अब क्वेश्चन आ गया HBr का अटैक करो तो कहाँ पे करोगे भैया? मिडिल पोजीशन. ये था Markovnikov, right? Okay. But in anti-Markovnikov, your answers are going to be exactly reverse of it. Now, why it is reverse? We'll talk about with the mechanism. So let's start doing it. I'm removing this whole thing on the count of 3, 2, and 1. So see. B2H6 is this compound. Please draw the structure of B2H6. So B2H6 is dimer of BH3. It's dimer of BH3. Dimer means 2 units of BH3 are fused. Then B2H6 will form. Okay. So this is the structure of B2H6 and you know boron is 1s2, 2s2, 2p1. 5 electrons होते हैं boron में तो उसका structure होता है 1s2, 2s2, 2p1. All of you know that boron का structure. So boron is 1s2, 2s2, 2p1. In excited state you can say 2s1 and 2p2. Excited state. Still, this vacant orbital is there, right? And this is the vacant orbital we are talking about. And these 3 places, hydrogen is forming bond. So, H is forming bond here, here, and here. So, I have given you VBT of BH3 also. Is that okay? Is it clear? Fundamentally, it is clear. 3 bonds with hydrogen and 1 vacant orbital. Any issues with this part? Yeah, excited state. Excited state में ये इलेक्ट्रॉन यहाँ से एक इलेक्ट्रॉन इधर आ जाएगा. पता है आपको? Okay. Now this dimer of borane like BH3, this is called diborane. इसका नाम होता है diborane. What is THF? Tetrahydrofuran. Tetrahydrofuran. Okay. THF is called tetrahydrofuran. What is furan? This is furan. If you remove this double bond and put hydrogen in this place, it will become tetrahydrofuran. It is like this. So tetra means 4, hydro means hydrogen. This compound is THF, this compound is furan. Furan आपने पढ़ा भी aromatic compound. Is it aromatic compound? Is furan aromatic compound? Answer is yes. Why is it aromatic compound? You know that because this lone pair, single double. If you move it, you can see the movement, right? 6 electrons are moving. Cyclic. Okay. sp2 hybridized. Planar. And 4n plus 2 pi electron group. So this is making it aromatic. Furan is aromatic. Yes or no? Anyone having doubt in this? Furan part आपको पता है. So tetrahydrofuranus, in a way it is a cyclic ether. Now the question is why this ether is taken as a solvent and what is the purpose of this in the given reaction? Yatharth, is it clear? Any doubts up to this? All of you are comfortable with this part? So what we have done so far is we have drawn the structure of B2H6, we have drawn the structure of THF so that we can understand what is happening in the reaction. Basically, I am trying to clarify what is step number 1. Is that okay? Chali. Now, just see the structure. In the structure, when you talk about this part, this is having lone pair. These lone pairs support one of the boron and then this BH3 is ready to cleave. Okay. So basically the purpose of this ether is to break the BH3 bond. See, BH3 is a very strong bond, right? It will not open up, it will not react. So you want someone to come and support one BH3 so other BH3 is free. That's what you are trying to do. Is it clear? So when this ether supports BH3, can I say this BH3 is happy because ether is supporting it? And this BH3 is now free for reaction. ये BH3 आ गया आपका बाहर reaction करने के लिए. Now you can say, sir, इतना कुछ क्यों करना था? BH3 ले लेते आप. लेके क्यों है B2H6? Advik, are you there? This can be a question. Sir, why are you taking B2H6? You take BH3 only. Please turn on a camera. So you can say why we are taking B2H6. BH3 ले लेते शुरू में. So you can't take BH3 because BH3 is highly unstable. BH3 is never available to you, right? BH3 is not available to you to use it directly. Is that clear? It will be always in B2H6 form. So the role of B2H6 THF is as in cyclic ether you are supporting. BH3 is highly unstable, okay? Highly unstable, okay? Yeah. So diborane is stable because it's dimerized form. Remember, any structure becomes stable, either you make it dimer or you get some kind of back bonding. So BH3 is not having any back bonding option, so it has an option of dimerization. Fine? Is it clear? अब BH3 आपके पास reactive BH3 आ चुका है reaction में. Where have to react? R, CH, double bond CH2. मान लीजिए इस पे reaction चल रही है. Okay? Or let's say, yeah, you can keep R. It's okay. R, you understand, like CH3, C2H5, any such group. Please tell me what is charge breakup on BH3. Which is plus, which is minus? In BH2 and H, which is plus and which is minus? Raunak? H is minus and BH2 is plus because boron is deficient unit, you already know. See, BH3 itself was deficient. If you take H also, how it can be having more electrons? Is that clear? So please, you can just rotate yourself like this. Yeah, so बार-बार लिखना है, आराम से लिखो है. Is it fine? Any difficulty? Advik, is it clear?
Yes, sir.
Astha, is it clear?
So could you repeat that point where you said that BH3 is highly unstable, but B2H6 is highly stable?
Yeah, because B2H6 is dimer of BH3. So wherever any unstable structure is given, you can make dimer or you can do back bonding to make it stable. For example, BF3 is stable because of back bonding and B2H6 is stable because of dimerization. So this is the situation, right? Now what is coming out of this situation? BH3. BH3 का breakup क्या होगा? BH2 and H minus. यहाँ तक समझ में आ गई बात? अच्छा जी, अब एक काम करते हैं. H minus कहाँ पे ज्वाइन करना चाहिए? बोलो. माइनस पार्ट कहाँ पे ज्वाइन करता है? आंसर. सो माइनस पार्ट जाएगा इधर, ठीक है? और ये कहाँ पे जाएगा? इस पे जाएगा। यही तो करते हो एवरीबडी। अब ये अगर आप भूल गए तो फिर एक बार प्लीज रिवाइज करने को बोलूँगा मैं, ठीक है? HBr का रिएक्शन में अगर भूल गए तो फिर ये समझ में तो कैसे आएगा, है ना? सो व्हाट विल बी द रिजल्ट? RCH, हाइड्रोजन इधर आ गया, NaCH2 के पास चला गया BH2। कितने बच्चों को समझ में आ गया? Raise your hand if it is clear. Everybody raise your hand if it is clear. Simple thing. Great. H minus and BH2 plus. So H minus negative part था, यहाँ पे join कर गया, BH2 यहाँ पे join कर गया. Now reaction is still continuing. Reaction is still continuing. Reaction अभी रुकी नहीं है. अब क्या करोगे आप? पहले इसको नोट कर लो, यहाँ तक पहुँच जाओ, फिर मैं आगे बढ़ता हूँ. Everyone please revise up to this part and ask if you have any doubt in this. You can ask if you have any doubt in this part. ठीक है?
THF is supporting the right?
THF is supporting one of the BH3s, so other BH3 is out. The BH3 which is out is attacking as BH3. Simple. Dhriti, is it clear? Okay. Anyone still writing? All of you have written? No, just आपको दिखाना है. Can I remove this whole thing? Okay, I'm removing on the count of 3, 2, 1. Okay. So let's rewrite again. RCH double bond CH2 reacts with HBH2. H was negative part, this was positive part. Okay, so this attacks here and this attacks here, and it forms RCH CH2 BH2. I hope this is fine. Same बात लिखी मैंने. Now you will bring another unit of RCH double bond CH2. एक और यूनिट लेके आ गया. कहा चलो भाई एक हो गया रिएक्शन, अब एक और से करते हैं. So please pay attention to this BH2. This BH2 which you have written here. Can I say this BH2 is BHH? Now this whole portion I'll put delta plus and this is new delta minus. Remember BH3 has 3 hydrogens, right? BH3 has 3 hydrogens. You have taken only one H. Now still 2 H are remaining with BH3. Yes or no? So this time what can happen? Negative part attacks where? And this part attacks where? कर लोगे? सेम काम किया फिर से हम लोगों ने. नेगेटिव पार्ट कहाँ पे अटैक कर रहा है? नेगेटिव पार्ट जा रहा है आपका H पे, CH पे, एंड डबल बॉन्ड अटैक करेगा BH2 प्लस पे. इज इट क्लियर एवरीबडी? कुछ अलग नहीं कर रहा हूँ, सेम ही काम कर रहा हूँ. हाँ, करेक्ट, राइट. अब प्रोडक्ट क्या बना यहाँ से आपका? What will it give? It will give RCH. Now I'm just marking this H for your understanding. This is first H. CH2. Then आपके पास B है. B के पास एक H है. इस B पे और आगे क्या अटैच हो गया? B पे अटैच हो गया CH2. इस CH के पास एक H अटैच है. और कितने लोगों को ये समझ में आ रहा है? If it is clear, raise your hand. 1 has become 2. Jia, is it clear? Now, Advik, is it clear? Advik जी, आप इधर क्यों नहीं आए आज?
तो आज मेरा आयन आना शुरू हो गया.
Okay. ठीक है. So, any difficulty in this part? RCH and CH2. Now, what is the next part? This is BH bond, right? In this BH bond, this is delta minus, this is delta plus. अब फिर से आप वही काम करोगे. क्या काम करोगे? अब फिर से एक RCH double bond CH2, one more RCH double bond CH2 will bring. So what's going to happen this time? Where is the negative part? Negative part attacks here. And where is this part going to attack? On the boron. कर लेंगे? So what's the outcome? What's the outcome? Now boron has lost this H also. इसके पहले ये वाला H यूज किया, उसके पहले ये वाला H यूज किया, सारे H लूज कर चुके हैं। एंड व्हाट इज नाउ कनेक्टेड हियर? क्या कनेक्ट हो गया यहाँ पे? वी हैव CH2, CHH, R, CH2, CHH, R, CH2, CHH, R. Take your time, take a deep breath, inhale, exhale, and then understand this and confirm. Take your time, there's no hurry. थोड़ा ज़्यादा हो गया? ईजी है वैसे तो, अगर समझ में आ रहा तो बहुत सिंपल सी मैकेनिज्म है। H माइनस BH2 प्लस, पहले देखो H माइनस गया इधर, BH2 पे अटैक हुआ, H आ गया, फिर दूसरा H माइनस गया इधर, फिर ये BH2 पे अटैच हो गया, दूसरा आ गया, फिर दूसरा H माइनस गया इधर, फिर ये BH2 पे अटैच हो गया, B पे अटैच हो गया। सो इवेंचुअली क्या बचा इसके पास? सी इफ दिस विल ज्वाइन B, सो B CH2 CH और H यहाँ पे आ चुका है। जो काम पहले किया वही दोबारा किया, वही तीसरी बार किया। So you will get this structure, boron having CH2 CHHR, CH2 CHHR, CH2 CHR. How many of you understand that these three hydrogens which I have, देखो आत्मा शरीर में है या निकल गई? Look at these three hydrogens. The source of these three hydrogen is hidden in this. कितने लोगों को समझ में आ रहा है? Yes or no? H is negative part. H negative गया और ये पूरा positive है. BH bond break कर रहे हो बार बार. Yes, Spriha.
Sir, I was asking, is it the same conjugation part just with the new E?
Conjugation part. What is conjugation in this case?
We're replacing the pi bond.
No, there's no conjugation. This is attack on pi bond. We are attacking on pi bond. We are attacking on pi bond with a plus and minus, which is basically electrophilic addition reaction. Spriya. Is it clear? Now this compound which you have drawn is known as, इसका नाम होता है tri, this whole thing I am calling alkyl, tri-alkyl borane. Okay, it was borane, this is tri-alkyl borane. Can you see these things? Tri-alkyl borane, 3 units of alkali, 3 units of alkyl on boron. This is reaction step number 1. This is reaction step number 1. Any difficulty in this? Step number 1, B2H6. So basically what you have completed is this step. 1, you wrote B2H6 THF. ये complete हो गया. अब आते हैं step 2 पे. What was step 2? H2O2 OH minus. Step 2 was H2O2 OH minus. That's simple step. That will not take much time. So when H2O2 OH minus is available, this bond you have to break, this bond you have to break, this bond you have to break. Write OH, 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 both side. अब चेक करो यहाँ पे क्या लिख दिया मैंने, ये पूरा कंपाउंड क्या बन गया? CH2 OH CHHR. Can you recall your product for HBO? It's the same thing that you have written earlier. Please check. RCHH-CH2OH. यही तो लिखा था शुरू में जब रिएक्शन शुरू की थी हमने, हाइड्रोबोरेशन शुरू किया था. This is the product. How many units will form? One from this, one from this, and one from this. 3 units of this will form. Yeah, this earlier thing was trialkyl borate, which was written earlier. Now when you put OH, 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 you get 3 units of alcohol. And the center boron is getting 3 OH connected like this. So what is this called? BOH whole thrice. Note कर लीजिए. ये byproduct है. This is my major answer. This is alcohol formation. Is that clear? Mechanism. See, अगर आपको IT जाना है तो ज़रूरी है. अगर आपको NIT जाना है तो थोड़ा थोड़ा ज़रूरी है। प्राइवेट कॉलेज वालों के लिए बिल्कुल ज़रूरी नहीं है, ठीक है। बोर्ड की तैयारी कर रहे हैं तो फिर आप रेस्ट ले लो, थोड़ा चाय वाय पी लो, कॉफ़ी वॉफ़ी पी लो, डिपेंड करता है, मतलब उम्मीद क्या है खुद से। तो आप बताइए, जानना ज़रूरी कि नहीं है रौनक जी? ज़रूरी है जानना, नहीं है?
हाँ जरूरी तो है,
ज़रूरी है, ठीक है।
तभी भी ज़्यादा चाहिए।
Okay. Now, if this double bond, is not taken, and let's say you take this compound, तो क्या changes होंगे? Let's say ये starting compound होता आपका, तो क्या क्या changes होते हैं? सोच के बताओ थोड़ा सा. Give it a thought. रौनक, if you use RC triple bond CH, not RC double bond CH, तो यहाँ पे क्या change होता है?
So product में कि
मैकेनिज्म तो सेम चलती जाती है, बट यहाँ पे क्या क्या चेंजेस होते हैं? What all changes would have been here?
sir, OH या R because the product में या कौन रहता है
Good. कहने से जहाँ जहाँ पे सिंगल यहाँ पे डबल बॉन्ड होता है हर जगह. Yes or no? Because see, if you start from double, you got single. If you start from triple, you got double, right? Is it clear? यहाँ पे डबल बॉन्ड होता है, यहाँ पे डबल बॉन्ड होता है, यहाँ पे डबल बॉन्ड होता है, ठीक है? Yes, I'll come to that. First, last part आप नोट कर लो सारे, फिर उसके बाद हम इस पे भी चलते हैं. We'll see this question also. Is this clear, everybody? Is it clear? The last section is clear? Last में कोई doubt?
So from where did this OH like come?
H2O to OH minus. We are giving H2O to OH minus, right? So this is the source of the reaction. Okay? Yeah, 3 units of alcohol and BOH whole thrice will form. And 3 units of alcohol. So my question to you was, if I replace this double bond and I would have taken a triple bond, what will be the change? So I hope all of you can observe that the change would be, your compound will be like this. See, 1, 2, 3. Huh? Please draw. If you start with RC triple bond CH, you react with B2H6 THF, you take 3 units of this is going to form. Is it clear now what I am trying to convey? Why it is formed? Is it clear? Same mechanism. Triple bond पे attack करोगे, H लगाओगे, उधर पे double bond पे form करोगे, and all these things will happen, right? Yeah. Fine. And if you give it H2O to OH minus, then what will happen? Yes, please. तो फिर से वही काम करेंगे अब. यहाँ पे क्या करेंगे? OH लगा देंगे. यहाँ पे क्या करेंगे? OH लगा देंगे. यहाँ पे क्या करेंगे? OH लगा देंगे. और इस B के साथ क्या भेज देंगे बाहर? 3 units of OH. कर लोगे? Is it not the repetition of same thing which we have discussed earlier? H2O to OH minus is basically OH minus has the nucleophile attacking on boron and breaking 1,1 part. Okay? So when H2O to OH minus is given, you have to go to the boron point and break this bond and assign OH both sides. Assign OH both sides, assign OH both sides. Okay? Yeah, BOH whole thrice will be coming out, these portions will get 1,1 OH. Is it clear? So if you look at this compound, what is this compound? It is RCH double bond CHOH. टॉटमराइजेशन पढ़ा आपने बचपन में, तो बचपन मतलब अभी का बचपन 11th में. तो ये टॉटमराइज हो गया, क्या बन जाएगा? RCHHCHO. This is called aldehyde. CHO is called aldehyde. अब कोई बोलता है मेरे को टॉटमरिज्म नहीं याद है, देन प्लीज रिवाइज करिए. ठीक है? इनॉल है, दिस इज इनॉल, this is keto, तो उसका aldehyde form बन जाएगा. This is your final answer because these are thermally more stable as compared to this case. Fine. What is name of this compound? What is name of this compound? That was trialkane alkyl borane. What was name of this original compound? No, alkyl nahi, alkenyl. This is alkenyl borane because this is double bond. No? Okay. Yes, please ask the question.
Sir, for the aldehyde counterpart, what stability that is required?
Thermal stability. See, this is enol, right? This is more stable thermally. At high temperature, this will form. Yeah, thermally more stable.
But why?
See, because aldehydes and ketones are thermally more stable than alcohol, right? So if you heat them, they will try to go into this format, right?
What's the reason behind this?
So reason can be, see, you can simply say that OH bond, this OH bond will be converted into C double bond, right? Hence it is becoming more stable because you OH bond को break कर सकते हो ना, water removal के chances खत्म हो जाते हैं. You can't remove water anymore.
So, sir, at like room temperature, we talk about the major product.
नहीं उतना डिटेल में मत जाओ भी. आप बस सिंपल इतना समझो कि ये जो है ये आपका मेन प्रोडक्ट आपको ड्रॉ करना है. ये ड्रॉ करोगे तो भी ठीक है, ये ड्रॉ करोगे तो भी ठीक है. सो यू शुड बी रेडी विद बोथ द ऑप्शंस.
But then, sir, how is the aldehyde counterpart main product if it's normally more stable? Depends on the temperature.
That's what I'm saying. At high temperature, this is more stable. If nothing is mentioned, please draw this product.
Okay.
Complete this. Try one question just for practice. Can I remove this? Draw the mechanism. Draw the mechanism and product. करिए. Product आपको पता है यहाँ पे OH आ जाएगा, यहाँ पे H. OH will come here, H will come here, right? But what is the mechanism? Draw the mechanism. Just for practice. पूरा mechanism, like BH, break it as BH3. Use THF, give it support, break this out, BH3 will be ready, delta minus, delta plus, yeah, everything. Then you have to attack, so this negative part will go and attack, here this part will go and attack, here, so what is the product? First level, what is going to form? CH, H, CH2, BH2. Again make delta minus, delta plus, bring another unit of this, CH double bond CH2, attack here, this part will go and attack, right? उल्टा हो गया. H, नहीं ठीक है. So what will it form? Ring, CH, H, CH2, boron, one H is remaining. On boron we have CH2, CH, H, ring. Again make plus and minus. Again bring another unit of this compound. So 3 units should be given. Even if they don't write, the meaning is that. What is the answer? Again this negative will go and attack here. This will go and attack on boron. It will become boron with CH2. एक बार लिखोगे खुद reaction तभी सीख पाओगे. If you're just watching me write, believe me, very difficult. If you start drawing it, again believe me, it will become very simple. This is trialkyl borane. After getting this trialkyl borane, step 1 is done. What do we do in step 2? H2OH minus. So you have to break this, mention BOH both thrice, mention OH, OH, NOH. So what's my answer? Your answer will be a 5-member break having H here, having CH2OH. This alcohol will be the answer. Is it clear? कर लेंगे, कोई समस्या इसमें, कोई प्रॉब्लम? अब इसी रिएक्शन का एक दूसरा भाई होता है जिसका नाम होता है ऑक्सीमर्करेशन डीमर्करेशन, बट अगर मैं बता दूंगा आज उसको तो आप ये भी भूल जाओगे, वो तो भूल जाओगे, ठीक है? सो द मैकेनिज्म ऑफ सेकेंड रिएक्शन विच इज कॉल्ड ऑक्सीमर्करेशन डीमर्करेशन, विल कीप इट फॉर द नेक्स्ट क्लास. मॉनिटर प्लीज नोट डाउन दिस, भूलना मत. रिएक्शंस नहीं पढ़ रहे हैं हाइड्रोकार्बन में, कौन सी पढ़ रहे हैं वो बताना पड़ेगा आपको. ऑक्सीमर्करेशन डीमर्करेशन. यू वांट मी टू डू द अदर वन आल्सो टुडे? आई थिंक दैट विल बी टू मच इन्फॉर्मेशन. तो पहले आज के लिए पहले इसको एब्जॉर्ब कर लो पूरा ठीक से. इसकी प्रैक्टिस कर ली आपने इसको, राइट? हाँ, क्या है? श्योर. B2H6 THF H2O2 OH माइनस में किसी को कोई प्रॉब्लम? आई डोंट थिंक सो. दैट्स अ वेरी सिंपल रिएक्शन. नाउ आई विल डू सम मोर वेरिएशन ऑफ दिस. इसी में थोड़ा और डिटेल में जाते हैं, एक दो चीजें और चेंज करते हैं, देन विल अंडरस्टैंड. कर लेंगे. Yeah, 3 units of this. So basically diborane will be in the control amount and this will be in huge amount. So automatically this will happen. What are we learning? We are learning reaction of alkene with this kind of compound. What is happening because of it? This is called OHH, so conversion to alcohol. Okay, this is conversion to alcohol. So there are 3 reactions to convert this into alcohol. One is this, other 2 I'll give you the names today, and we'll discuss some more things about this particular part. Is it clear everyone? कहाँ फंस गए?
ये BH2 में एक H बचेगा, नेक्स्ट वो इससे क्या करेगा?
हाँ, नेक्स्ट फिर से रेड करेगा. अब यहाँ पे एक H चला गया आपका, इसको एक H ऐसे बना लो. एक H जो बचा फिर से एक बार रेड करोगे, तीसरी बार.
सर ऐसा
Yeah, correct. Once again, Rona. इसे हाँ बिल्कुल, अगर आप हीट करोगे तो फिर वहीं पहुंच जाओगे ना जहाँ से चले थे. एलिमिनेशन हो जाएगा, बट फॉर दैट एलिमिनेशन यू नीड, डिहाइड्रेशन के लिए यू नीड सम एसिड प्रेजेंस, राइट? यू नीड प्रोवाइड सम H+ हीटिंग और समथिंग. ओके, चलिए. So can I remove this whole thing? Now, what are we discussing? This is having 3 parts. So first part, let's say which you have done, I'm calling it first part. So what you have done right now is hydroboration oxidation method. And as per your understanding, this is Anti-Markovnikov product without any rearrangement. कोई rearrangement देखा आपने? कुछ भी नहीं हो, जैसे जहाँ पे जो आना था आगे. The second reaction in the sequence is called oxymercuration. Oxymercuration, demercuration. Okay, what is the short name of this? HBO. What is the short name of this? OMD या OMDM भी बोलते हैं इसको. ऐसा कुछ भी लिखा मिल जाए, समझ जाए. Oxymercuration, demercuration. This gives Markovnikov product again without rearrangement. And the third reaction in this sequence is acid catalyzed hydration. So basically it is H plus H2O kind of setup. This is Markovnikov with rearrangement. Okay. आपने कौन सा पढ़ा अभी? First. These are different reactions to add OH on a double bond. So all these things are known to convert RCH double bond CH2 into alcohol. I'll show you what they will do.
So they give the same one.
I'm just telling the name right now. We'll talk about it in detail. Okay. First, you have done. These are three reactions. One is hydroboration oxidation, other is oxidation, third is acid catalysis. This we have discussed in detail. This we have to do. These two we have to do. Yes, Rona. What's the question?
These three reactions, they give the same product, but they have different
No. They will not have same product. That's what I'm saying. This is anti-Markovnikov product. I'll explain you what is meaning of it. I'll give with one example. So let's take this example. CH3, CH. I'll take some example which can showcase different product for these reactions so that you can get complete clarity about it. So let's say this is your reactant and you do reaction number 1. 1 कौन सी है? तो आपका आंसर क्या बनेगा? सभी को पता है. क्या बनेगा? एंटी मार्कोनिकॉव विदाउट रिएरेंजमेंट. कुछ बॉदर नहीं करना आपको. सीधा सीधा पता है मेरे को क्या लगाना है. कहाँ पे? CH3. क्या लगेगा भाई? इधर पे और इधर पे. आ गया? This is what you have learned today. Yes or no? यही तो सीखा है आज पूरी क्लास में अभी तक. OH बाहर, H अंदर. WOR means without rearrangement, WR means with rearrangement. हाँ, इसका फुल फॉर्म लिख देता हूँ. Without rearrangement. And this is with rearrangement. Reaction number 1, how many of you are clear with it? Raise your hand. 1. What we have done in last 45 minutes. 1. 1 में तो कोई डाउट नहीं किसी को. 1 पूरा समझ में आया. अद्वैत पक्का? Okay, good. So 1 is clear. आराम से इसको नोट कर लीजिए. तीनों के नाम नोट कर लीजिए. राइट डाउन ऑल 3 नेम्स. राइट डाउन 1. ऐसे ड्रॉ कर लो इस कंपाउंड को एंड शो दिस प्रोडक्ट. प्लीज कंप्लीट अप टू दिस एवरीबडी. Now, can I go to the second one? Second one is Markovnikov without rearrangement. So what do you expect? Anyone from online? Advik, what will be the observation? What will be the change here? OH कहाँ जाएगा? H कहाँ जाएगा? Advik. What should be answer for second case? Oxymercuration, demercuration कर रहे हो, Markovnikov चाहिए, without rearrangement चाहिए. What should happen? Okay. Yeah, बताइए Spreya.
The OH and H position will interchange.
Exactly. Advik, is it clear? Please pay attention. See, this is anti-Markovnikov, this is Markovnikov. So ये जो product है इसको exchange कर देता हूँ, ये तो काम है. इसमें ऐसा कुछ rocket science थोड़ी था. तो आंसर क्या होगा? CH3, 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 CH, OH and CH2H. I am changing the position of OH and H. Very good. Less hydrogen पे negative आना. पहला है ना negative. दूसरा Markovnikov है. नेगेटिव पार्ट कर लोगे. सेकंड कितने लोगों को समझ में आया कि सेकंड का प्रोडक्ट ही बनेगा. सेकंड के मैकेनिज्म भी डिस्कस करेंगे हम, राइट? बट एटलीस्ट द प्रोडक्ट इज क्लियर. फर्स्ट में ये, सेकंड में इसका उल्टा प्रोडक्ट. इज इट फाइन? नो रीअरेंजमेंट, नथिंग विल लीव द पोजीशन. कुछ इधर उधर नहीं होगा, सीधा सीधा आंसर बनेगा. बट थर्ड वन I'll do with some different color. Third one, see what is going to happen. Third, you can understand also. So third one we can explain, understand right now only, H plus with water. Step 1, pi electron bridge. You have H plus, first attack should happen with this, right? ये तो बचपन से पढ़ते हैं. तो क्या बनेगा यहाँ पे? CH3, C, CH3, CH3, CH plus, CH2H. कितने लोगों को ये समझ में आता है? कम ऑन, ये मत बोलना कि ये समझ में नहीं आया. So कुछ किया ही नहीं मैंने, डबल बॉन्ड लिया, इलेक्ट्रॉन ब्रिज था, H पे अटैक किया, प्लस चार्ज बन गया. Is it okay? This plus charge is how many degrees? 2 degree. And we all know how rearrangements can occur. ये पूरा मैंने कराया आपको डिटेल में. So कौन सा शिफ्ट हो सकता है बच्चों यहाँ पे? Which shift is possible? Methyl shift is possible. सबने पढ़ा है? Iha, Astha, Spriya, everybody. Advik, Tarun, Dhriti. So why this shift will happen? Because this is 2 degree. If this shift will happen, plus charge will come here and this CH3 will join here. तो क्या बना देगा? CH3, C plus, CH3. इस CH पे आपने लगा दिया ये CH3 और इसके आगे आपने लगा दिया एक और CH2H. Now remember this is plus charge. Now water will go and attack. Water will go and attack here. And what is the final outcome of this result? क्या बन के आएगा यहाँ से? CH3, C, CH3, C, CH3, CH2H. यहाँ पे water आएगा, then OH2 plus will be formed, and then this H plus will be taken up, and you get OH as the final answer. तो यहाँ पे मेरा final answer क्या बनेगा? See, OH is joining where? OH is joining one carbon away from hydrogen, not the same position, right? Is it clear, everybody? OH is joining to a different position. There is the rearrangement. J, is it clear? Okay. So we are using rearrangement in this case, and finally my answer is CH3, C, OH, CH3. इधर पे आ चुका है ये वाला CH3 और यहाँ पे जा चुका है H. So can you observe that you have converted this into alcohol, but with rearrangement. We are using rearrangement. That's why I'm writing with rearrangement. कितने लोगों को समझ में आई क्या? Raise your hand. Formation of 2 degree, modification to 3 degree, then water attack, and then H plus removed. Is that okay? Can you do that? Now why H plus is removed at the end? Because we need a neutral product, and H plus is used in catalytic amount. You have to pay back. See, catalyst है ये घर लेके नहीं जा सकते. It's like the goggles given in 3D movie. 3D मूवी देखने के पहले दिए जाते हैं, मूवी खत्म होने के बाद वापस ले जाते हैं. वो चुरा लेते तो अलग बात है. You can't take it away, no. It is to be used there only and paid back, give it back, hand it over. Reaction is over, hand it over. Catalyst को अपने काम. तरुण जी लॉन्ग बना रहे हैं. Any difficulty? ड्राई में डाल दीजिए. Is that okay? Now third one, actually you know, third one बहुत देर से करते हुए आए, right? बहुत सी रिएक्शन किए थर्ड पे, right? First one we have done today. Second one we can do today, but I will suggest कि इसको हम next class के लिए रखें. आज के लिए because ज़्यादा confusion ना हो जाए आपको mechanism. Yes. Any doubt up to this? पूरा समझ में आया? Any questions so far? Take a quick break of 10 minutes, resuming at 6:11. 6:11. बहुत दूर मत निकल जाना. अरे कितना चिल्ला रहे हो?
Was all the
7
क्या बोल रहे हो भाई? नहीं है, मैं अभी पीछे आ गया।
Come here.
Okay.
Come here. I'm here. What is it? Yeah, no recordings. One minute. Remember
Yesterday's album comes
last week? Yeah.
early.
That's all.
Everyone, welcome back. Join me quickly. Come. Try to answer this question. This is the reactant. These are the product. This is column 1 and this is column 2. You have to match 1 and 2. So let me call it A, B, C, P, Q and R. Match. C, P, okay. B. What about R? Be careful. Check what all you have written and apply and try to answer. First, write down the question. Everybody, please write down the question. Tarun, are you there? Astha, you are attending from a mobile phone?
Sir, tablet.
Okay. Jia, try to answer this question. Tarun, turn on your camera. Iha, turn on your camera.
Yes.
Yeah. What's the answer? B, Q, C, P, A, R. कितने लोग के आंसर आ रहे हैं? ये HBO कौन सा है इसमें? एंड ये वाला कर पा रहे हैं? If yes, then you understood the whole thing. Is it clear? Why? Because this is, if you see this product, hydroboration oxidation, it should be anti-Markovnikov WOR. तो आंसर क्या बना? OH बाहर जाएगा, आपने ऐसा बना दिया. No rearrangements are allowed. Oxidation, demagration, Markovnikov WOR. So आपने Markovnikov प्रोडक्ट बनाया विदाउट रीअरेंजमेंट. OH यहाँ पे आ गया. ठीक है, डबल बॉन्ड इधर है तो यहाँ पे OH आ गया. थर्ड केस इज H plus water. H plus water. Now third case, let me explain. This H plus will attack here. You will form this kind of structure. This is H. This is a plus charge. It's a 5-membered ring having a plus next to it. Ring will expand. Ring will expand. Plus charge will be here. यहाँ पे H लगा हुआ है ऐसे. Okay. Then this is a 2-degree position. You have another H. You can send it here. You can make a 3-degree position like this. Plus charge here. Water will attack on this. So what's final answer? Which is drawn here. कर लेंगे? Any problem with this part? So ऐसे questions आप attempt कर सकते हो. Is that okay? Okay, let's proceed further. Meanwhile, you can take note of it. So hydroboration oxidation mechanism is clear. Can I remove this? Everybody, have you written?
No, sir, don't.
Okay, take your time. Last class you've written oxidation and oxidizing and reducing agent also? अच्छा, list बनाई थी. Okay. Have you done syn hydroxylation? Online students, have you completed syn hydroxylation?
No, sir.
Okay. I hope you have written, all of you have completed this. Can I remove this? Astha?
Yeah, yes, sir.
Done? Anybody still writing? Excuse me. Syn hydroxylation. Hydroxylation is OH group coming, and syn means same side. Same side. So for example, if you're given this kind of double bond structure, you do syn hydroxylation, the outcome will be both OH joining same side. Okay. Normally you have seen reaction where one joins here, other joins opposite side, right? H idhar aaya, Br udhar gaya. OH idhar aaya, Br udhar gaya, right? You have seen that kind of reaction. But this is called syn hydroxylation. So syn means same side. Now what are the reagents for syn hydroxylation? This can be done with the help of dilute alkaline camenophore. Dilute alkaline camenophore, which is also known as Bayer's reagent. Okay. This can also be done with the help of OSO4 followed by H plus. Even if they write OSO4, Rupesh, please take him out. But like it. Osmium tetroxide. Osmium tetraoxide. Osmium. OS is osmium. Osmium कहाँ पे होता है? This is 26. So you go to D block and check group number. कौन सा? 3D6 है ना ये? 8. Osmium मिलेगा. ठीक है? So these two compounds are known for syn hydroxylation. Same side OH will come. Okay. Now write down example of anti-addition. Anti is opposite. So let's say you are given a double bond and you get this kind of connection. One joining here, other thing joining here, right? That's called anti-addition or anti-addition. Now, make down the list of anti-addition. Number 1, Br2CCl4. It gives bromine-bromine. So one bromine comes top, one bromine at the other side. HOBr. You know the breakup. HOBr is HO minus, Br plus. But they will be opposite. They can't be at the same side. Is it clear? Raunak, is it clear? Advik? Spreha? Okay. Similarly, let's say you are given HOCl. HO minus Cl plus. NOCl. So mostly all these reactions are opposite. One will come here, other group will come here, right? HOCl and NOCl. HOCl and NOCl. Okay. Yeah, these are reagents. These are all anti-addition. This can give anti-addition. This can give anti-addition. This can also give anti-addition. This can also. In general, all the reactions are anti-addition, right? Okay. So fine. So can I say syn hydroxylation examples are very rare examples where syn will happen. Otherwise, mostly it is anti. Okay. HOBr, HOBr, HOCl, NOCl. Yeah. HOBr, HOCl, NOCl. Not only these, I can write n number of things. Mostly they will all be anti-addition. Okay. So anti-addition is pretty much common, right? But syn is not that common. Now let us see a certain question on this logic and try to understand what is happening around. First thing is, dilute alkyne cheminophore Bayer's reagent is also called test of unsaturation. So if you have any double bond, triple bond, you can always use this reagent as a reacting substance. It shows color change. Based on that, you identify that this is showing unsaturation. So test of unsaturation likh lijiye. Cheminophore is test of unsaturation. Dilute alkyne cheminophore is test of unsaturation. Yeah, we'll discuss that also. Fine. Now let's discuss some mechanism part of this, how the reactions are giving you syn and anti. एक एक केस दोनों के करते हैं. Can I remove this if you have written, all of you? Anyone still writing? Okay, so removing on the count of 3, 2 and 1. So let's do both the things parallel. Draw this kind of line. and take this compound, take osmium tetroxide, this kind of compound, and other side you can take this, take Br2CCl4 and see what is happening in both the cases. So in this case, what is going to happen? This is electron rich and this is OS, right? So how do you proceed for this reaction? See, this reaction goes like this attacks here, this goes here, and the bond, let me just draw it here. H plus will come later. ये डबल बॉन्ड है, ठीक है. So ये, can you observe that osmium tetroxide is forming this kind of linkage on the given structure? Check please. Okay, ऐसे एक लिंक बना देंगे. This kind of cyclic formation will happen. Yeah, this is also test of unsaturation. Same thing KMnO4. अगर यहाँ पे KMnO4 लिखूँगा तो क्या लिखूँगा? Mn डबल बॉन्ड O माइनस कोऑर्डिनेट. सेम काम करोगे MnO4 के साथ, right? Now, what is role of H plus or H plus with basically H plus? When I say H plus is with water. So, what is the role of water? Water molecule has a nucleophile attack and these bonds become free. Other unit attack, this bond becomes free. When they become free, can I say the structure will have O minus hanging like this, and you have presence of H plus to make it OH, OH. ये ऐसा structure है. So the key reason why OSO4 is showing syn hydroxylation is the complete unit joined from one side. Just see the structure. This complete unit joined from one side. ऐसा नहीं हो रहा है कि एक part इधर से जा रहा है, एक part उधर से आ रहा है. This whole thing joins from one side, right? And when water molecule will attack, this bond will be free. The next will attack, this will be free. Basically together it happens. And eventually, rather than showing multiple steps, you can say this with H plus forming this bond. Okay? दोनों OH एक तरफ आ जाए. यहाँ पे क्या होगा? This will be out. This will be out. OS double bond O, जो भी है H2O के साथ ये बाहर निकल जाएगा. That is the byproduct. So our main aim is focusing on this compound. We are not bothered about the second part first, right? Now see the other side. What is happening in this question? Okay. Or if you want to take, I'll take a general case which will help you in maximum cases. Let's say HOBr case. HOBr में क्या करोगे? HO minus Br plus. आप बोलोगे भाई ठीक है, double bond, ये attack करेगा Br पे. So if this is formed, plus will be joining here, and then OH minus will come next, but it will approach from opposite side. So this is what we are trying to form. Can you observe? We are keeping it opposite side. Yeah, because this can break, right? This can easily break. Okay? This is not breaking, this is joining as a unit. In this case, it is breaking into two parts. One part joins and then other part. So other part approaches from other side. The reason? What is the reason? Write down the reason for this. To avoid hindrance. This one? This is for water only. I said both the molecules will attack. Okay. To avoid hindrance, it will always be opposite. Always opposite. So one reactant has joined, one part has joined from front, other will go from back. This is the basic tendency of all the reaction. And why do they do that? To keep their delta G minimum, so that they can be stabilized, right? Repulsion कोई भी नहीं चाहेगा. Is that clear? So can I say in simple words, mostly all the reactions are anti-addition. सभी जगह anti-addition होगा. Syn के example बस 2-3 है. तो आपको क्या prepare करना है? कि आपको एंटी के सारे प्रिपेयर करने हैं? नो. आप सिन के प्रिपेयर कर लो. सिन के अलावा बाकी जो बचेंगे सारे एंटी. इज इट क्लियर? इज इट क्लियर? आस्था? एक्सेप्ट सिन, ऑल अदर्स विल बी एंटी. धृति, इज इट क्लियर? जिया? सो if you know sin, other one is anti. अब इसका काम क्या है, ये क्यों सीख रहे हैं? Why are we learning the sin and anti, and what's the role of this? Let's try to understand that as well. Let's try to understand that as well. Why this OH is coming from back side? So this goes from front, this goes from back. Why? Okay. Basically, it's as simple as you have to go from position A to B. You will use minimum traffic or maximum traffic. That's a tendency of product also. Okay, it will use minimum traffic. Minimum traffic means minimum steric hindrance, minimum crowding, minimum steric crowding, कुछ भी बोल रहे इसको, right? So that it becomes a stable one. But why this is doing opposite? Because इसका compound ही ऐसा है भाई. अब OSO4 टूट के थोड़ी जाते हैं, पूरा एक साथ यूनिट जा रहे हैं, तो इसको दोनों एक साथ यहाँ पे फिक्स कर देंगे. Delta G becomes lesser. Delta G less होने का मतलब क्या हुआ? Stability ज़्यादा. Minimum delta G is more and more stable structure. Thermo में क्या है? Is that clear? Now let us try to apply this in some questions. This discussion in some questions. Anyone still writing this? All of you have written? Jia, Dhriti, Spriya. Done? Can I remove this? Okay. Now see, why are we discussing this? There is a purpose of this whole discussion. So what is the purpose? देखिए. Let's say you got a question. CH3, C double bond C, CH3, HH, CH3, C double bond C, CH3, HH. What is the difference in these two? पहला वाला cis है, दूसरा वाला trans है. Look at hydrogen, same side, opposite side, cis, trans. Okay. Now, this is cis and trans. Now, let's say we talk about syn and anti-reaction. यानी ये मैंने cis compound लिया, this is trans compound. On cis compound, if I do syn addition, it gives you meso formation. लिखते चलिएगा, समझाऊंगा. Cis, syn is meso. But if you take cis compound, do anti-addition, it gives racemic mixture. If you take trans compound, you do syn addition, it is going to give racemic mixture. And if you take trans compound, do anti-addition, is going to give meso form. पहले इसको आप नोट कर लीजिए, फिर इसका मतलब क्या है वो भी हम समझते हैं. So what is meso? Meso, अगर if you recall, meso means plane of symmetry, right? So let's say this is the compound. I have to draw the meso of this compound, and let's say I have to put OH for instance. आप cell addition कर रहे हो OH, तो आंसर कैसा बनाओगे? CH3 on top, CH3 at bottom, H, OH, H, OH. This is syn. This is a meso compound. Okay. So syn hydroxylation. If I'm doing syn hydroxylation, I have to put OH group, and it will come like this. Let us say I'm doing anti hydroxylation. अभी anti hydroxylation का एक केस करेंगे हम लोग. तो मेरा आंसर क्या बनेगा? सिस कंपाउंड पे एंटी हाइड्रोक्सिलेशन करोगे तो क्या बनेगा? रेसिमिक मिक्सचर. हाउ विल इट लुक लाइक? CH3 top, CH3 bottom, H, OH. Don't write HOH, write other way around. And write its mirror image also. This plus its mirror image.
50% of the
Yes, 50% of each. So this is called POE, pair of enantiomers. And they are in the ratio of 1:1, equal chances. Hence it is called racemic mixture. तो समझ में आया? सिन मीजो समझ में आया? मीजो इज व्हाट? मीजो में प्लेन ऑफ सिमेट्री होती है. फिशर प्रोजेक्शन किया आपने क्लास में. OH बिलो OH, CH3 CH3, H बिलो H, राइट? इसमें उसका उल्टा लग रहा है, OH इधर आ गया. इसी का मिरर इमेज ले लो. These two things are different from this. So ये पेयर होता है पेयर ऑफ enantiomers. These are mirror images. Cis को, this is cis compound. You do syn, you get meso. But you do cis compound, but do anti-hydroxylation, you get this product. यानी अगर यहाँ पे OSO4 यूज किया है या आपने dilute alkaline caminophore यूज किया है, so syn addition, syn hydroxylation. Anti चाहिए, you should use RCO3H followed by H3O plus. लिख लीजिए. Anti-hydroxylation हो गया. This is example of syn hydroxylation. This is example of anti-hydroxylation. There are two aspects, right? First thing you should know what will form. Second thing is how will it form. How बाद में आएगा, पहले what पता चलना चाहिए, right? हाँ, trans with syn will be same as cis with anti. Of course, इसको ऐसे समझो ना, trans with syn and cis with syn same नहीं हो सकते ना. So if you know just one thing, all other things can be taken up. Now this is little complicated, but I'll make it very simple for you. With the help of this small code, you can always answer any question. So remember, you are sitting in a, what is this? What is this? Car. लग रहा है car? Good. So my drawing is good. This is a car. Let's write car. You are sitting in a car and you're going to an ATM. ATM. ये पिक्चर दिमाग में रहेगी. That's it. And बैंक का नाम आप रख लो CSM बैंक. कौन सा बैंक है? CSM बैंक. अभी RST के लिए आप ABCD पढ़ते हुए जा रहे हो. ABCD. By the time you reach the ATM, you are reciting RST. अब इस पूरी कहानी में से कुछ भी एक चीज याद रहेगी आपको. If car you can remember. चलो कार नहीं याद. ATM you can remember. ATM नहीं याद है. बैंक का नाम you can remember. Okay. कुछ एक याद कर लोगे तो बाकी निकल आएगा. Because if CA is R, then CS cannot be R, so it is meso. If CA is R, so trans A cannot be R, it will be meso. ATM. If trans A is M, trans syn will be racemic. Is that clear? If you know one, you can always derive others. Is that clear? Dhriti, is it clear? Jia, is it clear? So, if let's say you know car, you can again go for other cases. So, write cis anti racemic. Note कर लीजिए code एक बार. Cis compound anti addition racemic mixture. Cis compound syn addition meso. Trans compound anti addition meso. Trans compound syn addition racemic. ये भी note कर. Draw the picture. Note on this table. Draw these structures. Many questions have been asked on this in last 15 to 20 years. Many means many. मतलब 10, 15, 20 बहुत सारे questions आ चुके. अब देखो ना, CA अगर R है तो CS थोड़ी R हो. CA भी R है, CS भी R है, तो कैसे हो सकता है, right? So just one code is enough to crack the whole code. One code is enough to crack the whole code. Is it clear? So if you know CAR, of course you know CSM. And if you know CAR, you know TAM. If you know TM, you know TSR. How many of you understood this whole discussion so far? Raise your hand please, if it is clear. Okay, very good. Now, the only challenge here is, you know the mechanism, which is anti, which is syn. And you should know how to recognize cis and trans. Then you can solve any question. Let's try out some questions on this. First, you please note down the whole thing. Have you written everything, all of you? Anyone still writing? Done? Can I remove this? Tarun? Tarun, done? Okay, चलिए इसको remove करते हैं और एक question solve करिए. So now this question I'm giving you is reaction with Br2CCl4. Now Br2CCl4, you should know what is the mechanism. You please take care of it. आपको पता होना चाहिए. This is CH3. This is CH3. H. What is the product? Again, I'm not interested in mechanism right now. Just tell me the product. What is this compound? Trans. What is this reagent doing? Syn addition or anti-addition? Br2CCl4, Br2CCl4. Bromine इधर से आता है, chromine इधर से आता है. Okay. See, syn के, I again repeat, syn के examples limited है. OSO4, KMNO4. Okay. और maximum nickel hydrogen, platinum hydrogen, जो hydrogenation करता है, that is syn. Mostly all other things are anti, right? So this is Br2CCl, this is anti-addition. अब बताइए, trans anti should give you what? ATM, anti-trans meso. Meso. अब meso कैसे दिखता है? So CH3, meso बनाने का सिंपल तरीका है. CH3 अलग-अलग कार्बन पे है. You need Br, HBr ड्रॉ कर दो. HBr ड्रॉ. This is plane of symmetry. And this is a meso compound. Meso is optically active or inactive? Inactive. Dig deeper and try to understand that the structure which is drawn, if I just open it up in Fisher projection और सिर्फ कराया मैंने क्लास में, can I say both the CH3 will be down and H one side and Br other side. चेक करो ये पिक्चर, समझ में आती है आपको? This is same as this. कितने लोगों को समझ में आते हैं? यही तो vertical part you just fold inside like a table and then you see HBr. HBr, both the CH3s folded inside. I hope this is clear. This is the Sauer's projection. Plane of symmetry. Plane of symmetry. Now if you rotate this structure, please understand then right. Yathard, एक बार पहले यहाँ pay attention. If you just rotate it, can you say this structure if you rotate by 180 degree, the same structure can become H, Br, CH3 downward, CH3 up, Br इधर और H इधर. Check करने के लिए, see this is opposite, H opposite H. See the next line, Br opposite Br. See the next line, CH3 opposite CH3. Exactly उल्टे हो जाएंगे. Meso, they have to be opposite. Meso में बिल्कुल opposite होगा, ठीक है? This structure is, see remember this structure is same as this structure. There is nothing different. This is also same as this. These three are same structure. If you have any doubt, please revise Fisher, Sauer's, Newman projection. इसका Newman बना लेते हैं. Newman will be like this. CH3 at the back, Br this side, H this side, Br in the front, H here, CH3 at bottom. थोड़ा सा इसको और अच्छे से बना लो. ये कार्बन है. This is a carbon and this is a carbon. What? This is either way. You're seeing from front or back. Okay. This is one carbon. This is other carbon. हॉलो ऐसे हॉलो मतलब यहाँ पे हमने कुछ बनाया नहीं है, आई एम जस्ट ज्वाइनिंग इट. No, 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 it's okay. Yeah, yeah. Yes, please, Tarun. Inactive, optically inactive, mesoform. ये सारे स्ट्रक्चर इनएक्टिव है, प्लेन ऑफ सिमेट्री है. प्लेन ऑफ सिमेट्री और सेंटर ऑफ सिमेट्री. If you can find any of these two compound become optically inactive. Yes or no? ये सब हम लोगों ने GOC में बहुत डिटेल में किया हुआ है, बहुत ज़्यादा डिटेल में किया है. If you feel any difficulty, please revise GOC again. Okay? If you need any help regarding watching videos and all, please connect Rupesh ji, will provide you videos also. Rupesh ji, GOC के videos अपने पास सारे? GOC नहीं, GOC जो ऑर्गेनिक पढ़ा था बच्चों ने, P2 बैच, वो सारा ठीक है. Okay, I'll give you one simple hint once again. CH3 opposite CH3, Br opposite Br, H opposite H. This is one way to find out meso. CH3 opposite CH3, Br opposite Br, H opposite H. Another way to find meso. If you just tilt the whole thing, CH3 overlapping CH3, Br overlapping Br and H overlapping H, that's also meso. This is also plane of symmetry. The same thing if you draw in Fischer projection, this is Fischer projection. CH3, CH3, HH, Br, Br. ये सारे structures एक ही हैं, कुछ अलग नहीं है. Advik, is it clear? Any difficulty? Any issues? Please draw all these things. Trans compound, anti-addition, this is your answer. Answer is meso. Please note down this whole thing. Question I'll show. We'll solve some questions. It's
Sir, sort of supported Fisher projection.
I'll revise for you, don't worry. Okay? Please note down these things. Yeah. Any problem up to this? Any issues? Anybody? चल इस पे एक क्वेश्चन सॉल्व करके देखते हैं. Just a minute. Yes. So write down one question. Please draw the product. Draw the product. So this is cis. You are doing what? Anti-addition. Breakup is very clear. HO minus, Br plus, you know that. So what should it give? Racemic mixture. This is trans. You are doing anti-addition. What should it give? Meso. What will join? Br2C0, what will join? BR. What will join here? OH in BR. I hope it is clear.
Yes, sir, I have composition currently, but
No, I'll just leave it in 5 minutes. Just give me 4 minutes. I'm just ending. So what's the answer? Everyone has Pankaj sir's class, right? Yeah, all of you have maths class. So I'll just leave in 2 minutes. Just complete this question, then we can close it. CH3, CH3. Now, see, the simple practice I'll tell you, cis anti-racemic. So while forming racemic, please keep in mind that meso avoid karna. Meso avoid karna, to H idhar draw kar do, H idhar draw kar. And just copy what is going to come, OH and Br. Can you do that? That will always help you in solving questions without problem, right? What is its mirror image? Mirror image क्या होगा? CH3, CH3, OH left, H right, H इधर, Br इधर. इसका mirror image. ये दोनों मिलके क्या बना देंगे? RM. Why RM is my answer? Cis anti-racemic. Okay. Is that fine, everyone? The next question is trans anti-meso. To get meso, you have to get CH3 on top, CH3 at bottom. Both H same side copy कर लो because you have to draw meso. Meso में same रखना है आपको. तो यहाँ पे क्या आएगा? इधर भी यार. Can I draw its mirror image? No point. This is inactive. इसका mirror image कुछ है ही नहीं. So this is your meso. आ गया? So we'll end the session here only, 6:56 already. Take 4-minute break and then you can attend maths class because sabhi ka maths class hai. This was an extra session for B2 batch because we missed class yesterday. Wednesday को class नहीं हुई और Monday को भी combined class हो गई थी physics की. So to compensate that, this class was kept. I hope it is clear, everyone. Any problem, right? I require 2 more classes to complete hydrocarbon. 1 to conclude alkene and start alkyne, and other to conclude alkyne and practice. 2 classes for this. And in ionic equilibrium, where exactly you are? In ionic कहाँ पे आप लोग? Buffer कर चुके हो?
Yes, so we did that.
Salt hydrolysis कर चुके हो? Salt hydrolysis कर चुके हो पूरी? हाँ, weak acid weak base case कर लिया था चारों केस ना?
So
Buffer भी कर लिया है? ठीक है. So ionic you need 2 classes. So next week में हम लोग सारी चीज़ें complete कर पाएंगे. हाँ, ये नहीं, ये है hydrolysis. ये हाइड्रोलाइसिस कंप्लीट कर लिया आपने. बफर भी कर लिया ना आपने? हाँ, बफर कर दो लिया. यही बफर है. इसके पहले आपने वीक एसिड वीक बेस स्ट्रॉन्ग बेस सब कुछ किया हुआ है, राइट? सो वी आर लेफ्ट विद इन आयोनिक वी आर लेफ्ट विद मॉनिटर प्लीज नोट डाउन. इन आयोनिक वी आर लेफ्ट विद व्हाट आर वी लेफ्ट विद? टाइट्रेशन कर्व, एसिड बेस टाइट्रेशन कर्व, एंड आफ्टर दैट रिमेनिंग थिंग्स. या आपकी अलग से क्लास होगी तो आपको समझ में, इसलिए उसके पहले हम क्लास कर लेंगे आपके साथ. डोंट वरी. ओके, ठीक है. और इधर पे हाइड्रोकार्बन वी आर डूइंग एल्कीन एंड एल्केन. फर्स्ट वी कंप्लीट हाइड्रोकार्बन, तो वो आप अटेंड करो रौनक. ओके ओके, चलिए, टेक केयर, बाय.
Thank you, sir.
Bye.
thank you, sir. Thank you, sir. Thank you.
बाय, टेक केयर.
Can we write BR and H above H in
BR and
BR and H above H? मतलब H
उससे कोई फर्क नहीं पड़ता. ऊपर कर लो नीचे कर लो, उससे कोई फर्क नहीं पड़ता. दैट्स ओके. बट आप बस इतना ध्यान रखना कि H सेम साइड मत लिखना, मतलब इस वाली फॉर्मेशन मत लिखना. OHBr ऐसे लिखोगे तो वो अलग चीज़ बन जाती है. वो बनेगा जब आपका सिन एडिशन हो, इसमें नहीं बनेगा. ठीक है, डन. समझ में आया पूरा? अब इसको रिवाइज जरूर करना, अदरवाइज ये उड़ जाएगा पूरा. अभी 9 तक यहीं पे करोगे अपना क्लास? 7 to 9 नहीं करना? क्लास हो गया? क्या बच गया बेटा? खुशी की लहर दौड़ पड़ी। ये ऑफ कर देंगे माइक तरुण जी? हाँ एक बार